Most of the materials that surround us in everyday life are not at all simple when analyzed by chemists. There are over 90 natural elements, of which only a few are found in abundance. The atoms of the elements can join together to form molecules and combine with other molecules or simply mix together. All these molecules form the materials of our world, or the matter we see around us that are either solids, liquids, or gases. Hi, I'm your host, Lourdes Carale. Welcome to the telecourse for elementary science teachers. In this episode, we shall learn in depth about the concepts of solids, liquids, and gases. But before we start, let us review last episode's lesson on the forest cover and its importance to the biosphere. Question: what are some of the benefits we derive from forests? Answer: forests are a source of hardwood for building homes and furniture. They are a source of food since many of our farm produce originated from the forest. Many raw materials for medicine are found in the forest. How do forests regulate local and global climates? Answer: forests take in carbon dioxide, which is one of the greenhouse gases, and give off oxygen, which we need to breathe. Forests contribute to local rainfall and recharge the water in springs and streams. Question: why should we strive to prevent the further destruction of our forest cover? Answer: the preservation of entire forest habitats will save endangered species of animals and plants from extinction. Forests prevent soil erosion, which leads to river siltation and flash floods. Our own lives are linked to the forests, and if the forests die, we may eventually perish as well. By the end of this episode, you should be able to answer the following questions. How do the properties of solids, liquids, and gases differ? Describe what happens when a solid melts into a liquid. Describe what happens when a liquid evaporates. What are some of the everyday activities that make use of the properties of solids, liquids, and gases? Join us for today's lesson on solids, liquids, and gases after this short break. Soil is a solid, just as rocks, books, wood, and clothes are solids. Water is a liquid, just as milk, gasoline, vinegar, and blood are liquids. The air we breathe is a mixture of many different gases, like oxygen, nitrogen, and carbon dioxide. Although we cannot see the air around us, we know it is there from the ways it affects other materials. Solids, liquids, and gases are states of matter. These states may change. Depending on certain conditions, solids may melt into liquids, and liquids may freeze into solids. Whenever a solid changes into a liquid, it is said to be melting. And whenever a liquid changes into a solid, it is said to be freezing, even if it isn't cold to the touch. Liquids evaporate into vapor, and vapor condenses back into liquids. Evaporation is the change from liquid to gas. Condensation, on the other hand, is the change from gas to liquid. And sublimation is the change from solid directly to gas. When newly washed clothes are hung out on a clothesline, they become dry. After a rainstorm, wet roads dry up. And after a bath, wet hair becomes dry again. So, where does the water go? It evaporates and becomes water vapor. When a cold liquid is placed in a glass, drops of water form on the outside surface of the glass. When you blow air onto a piece of glass like a mirror, a fine mist forms on the surface. Where did the drops of water and the mist come from? They condensed from water vapor in the air. When mothballs are placed in a cabinet, they gradually become smaller and disappear. And when dry ice is taken out of a freezer and placed in a room at ordinary temperature, it soon disappears without a trace. Where do the mothballs and dry ice go? They sublimate directly into gases. One way to distinguish between solids, liquids, and gases is by observing their shape. Solids have definite shapes. They retain their own shapes independent of their container. Liquids, on the other hand, have no definite shape, and instead, they take the shape of the container. Gases, too, lack a definite shape. They not only take the shape of the container, they also fill it up. Volume is the term used to refer to the amount of space that a solid, liquid, or gas occupies. Solids and liquids are said to have fixed volumes, meaning that their volumes can be measured easily. On the other hand, the volume of a gas is not definite. It will occupy all the space inside its container, whether the container is large or small. All solids, liquids, and gases have mass. The mass of solids and liquids are easy enough to measure. Just choose an equal arm balance. But did you know that it is also possible to measure the mass of a gas using the equal arm balance? We'll show you how after this short break. How is it possible to measure the mass of a gas using a balance? You can try this activity in your classroom. The materials you will use are the following: 2 balloons of the same kind, improvised beam balance. And this is the procedure. First, suspend the balloons from the balance like this. You will notice that they have the same mass. Next, blow air into one of the balloons and suspend it from the same end. What happens? It is clear that the balloon with air in it has greater mass than the empty balloon. Thus, it may be inferred that the air inside this balloon has mass. be easier to understand and explain the observed differences in the properties of solids, liquids, and gases by adopting a model to help us visualize what we cannot see. The three states differ in the degree of packing of molecules. In solids, molecules are packed very closely together. The rigidity of solids suggests that something holds the molecules together. Forces of attraction exist between individual molecules. The closer the molecules are, the stronger the intermolecular forces of attraction, the more rigid a solid is. But even if the molecules in a solid appear unmoving with respect to each other, they are far from motionless. Molecules vibrate on their own because they possess kinetic energy. This energy varies depending on external factors like temperature and pressure. When high heat is applied to a solid and its temperature approaches its melting point, the intermolecular forces of attraction are sufficiently weakened by the increased movement of its molecules until the solid melts and changes into a liquid. Its molecules begin to behave very differently. Layers of molecules start to slide over each other. This is why liquids flow and conform to the shapes of their containers. If more heat is applied to the liquid so that its temperature approaches its boiling point, its molecules begin to move very vigorously, moving farther apart and finally breaking free of intermolecular forces of attraction. The molecules escape out of the liquid phase and the liquid begins to evaporate until it becomes a gas. These same intermolecular forces, especially in solids and liquids, prevent them from expanding or compressing, since they have attained the most stable packing distance. When we return, we'll take a look at how people have learned to use the properties of the states of matter. Stay with us, please. One of the ways we use our knowledge of changes in states of matter is very familiar to you, since it happens every day. It happens every time you use steam to cook fish or when we freeze meat to preserve it. Can you think of other ways we use the properties of solids, liquids, and gases to make our lives better? The hydraulic system that operates the brakes on a car takes advantage of the incompressibility of brake fluid, a liquid. The liquefied petroleum gas or LPG that we use to cook with came about because we learned to cool petroleum gas to the point that it liquefies, so that more of it could be placed in tanks for household use. The same thing is done for butane gas. That's why we have disposable lighters. We also know that water vapor condenses back into a liquid and leaves impurities behind. In this way, we can produce distilled water for personal or industrial use. There's one other property of liquids, particularly water, that explains how trees and plants transport water from their roots all the way up to their topmost leaves. It's called capillarity. The simplest way to observe capillarity is to take a very thin piece of glass tubing with a narrow inner diameter and to lower it vertically into some water until its bottom end just breaks the surface. It will be seen that the water rises inside the tube to stand about 2 to 5 centimeters above the outside water level. What happens is that the molecules of water are attracted to the surface of the glass and start to spread over its surface. Since these water molecules attract each other, the advance of the water film results in a rise of water in the tube. It stops when the weight of the water that rises equals the upward pull created by capillarity. Since we've seen that trees and plants have vascular tubes many times thinner than the glass tubing, it is easy to understand how water absorbed by roots can rise several meters to reach leaves in the plant's topmost branches. Matter is anything that occupies space and has mass. Matter can ordinarily exist in 3 physical states: solid, liquid, and gas. Solids have form. They also have hardness and rigidity, or the ability to oppose a change of shape. Liquids have no shape of their own, but they have the ability to flow. They take the shape of any container in which they are placed. All gases, regardless of the composition of their molecules, have almost identical physical behavior. Compared with liquids or solids, they have low densities. They exert pressure equally in all directions. They are compressible. States of matter may change depending on certain conditions. Melting is the change from solid to liquid. Freezing is the change from liquid to solid. Evaporation is the change from liquid to gas. Condensation is the change from gas to liquid. Sublimation is the change from solid directly to gas. Volume is the term used to refer to the amount of space a solid, liquid, or gas occupies. All solids, liquids, and gases have mass, meaning they all have weight that can be measured. The 3 states of matter also differ in the degree of packing of molecules. We have learned that understanding the properties of solids, liquids, and gases leads to improvement of technology and our way of life. As we discover more about these substances, how they behave under varying conditions, we must temper our knowledge with a greater understanding of the world we live in. I'm Lourdes Carale. Join us next time for another episode of the Telecourse for Elementary Science Teachers.